Good day, dear colleagues. Welcome back to video 3. We're looking at the last type of questions that they may ask you in examinations regarding graphs and how to approach them and how to also use the calculator effectively to ensure speedy working through the processes. So our question asks us to draw the graph of f of x is equal to tan of x plus 1 and g of x is equal to cos 2x, for x being an element of negative 180 degrees and 180 degrees. Must be drawn on the same set of axes. And then they ask us to show the intercepts with the axis, the turning point and the asymptotes clearly. Firstly, we will take our calculator. We will start typing in the information on the calculator. Do a small little video indicating what is required and how we're going to go about to capture this information. So the first graph is tan. So we first select the table method, that is 3. So we use tan of alpha x, close the bracket, and then there's a shift of plus 1. The second graph that we are doing is the cos graph. So we press cos of 2 alpha x, close the bracket, and we press equal. And then we have to start somewhere. The information given tells me I must start at minus 180, right? And I must end at positive 180. And my steps or my increments that I will work with is 15. Says insufficient memory, so we change the increments to steps of 30. So there the calculator displays all the possible answers that I'm going to need to draw my graph. So I populate a table with the values and then I start drawing the graph. Right? So there's all the values up till 180 degrees. There I notice also on the calculator that the two graphs are equal at 180 degrees. They both 1. At 0 degrees they are both 1. And at minus 180 degrees, both graphs is equal to 1. So now I plot all my values for my tan graph. I plot all my values for my cos graph. And then with one gentle continuous curve, I connect the values through the coordinates that was plotted for the cos graph, for the tan graph, for the tan graph, and the tan graph. Now, you will notice on this graph I've highlighted points of intersection clearly because this is the coordinates where the turning points will happen, as well as the coordinates where the x-intercepts will be, as well as where the y-intercept will take place. Now these coordinates can be labeled, could be labeled as these, or I must just make sure that the coordinates where that intercepts happen, that they are labeled properly. One other thing that was asked is to indicate the asymptotes. So we know at 90 degrees there will be an asymptote, and at negative 90 there will be an asymptote, and this needs to be indicated appropriately. If it's not indicated, I won't get my marks for that asymptote. Right? So we go to the next question. Ask me what is the period of g. Now g is the cos 2x function. So the period for a normal cos graph happens within a span of 360 degrees. So what happens now is I take 360 degrees and I divide it by the 2, and then I get a period takes place within 180 degrees. So it takes 180 degrees for a full cycle of this graph to complete. The next question. If h of x is equal to negative cos 2 into x plus 10, describe fully in words the transformation from g to h. Firstly, we notice a negative sign. So the graph is still the same, but there's a negative sign, which means there's a reflection about the x-axis, meaning the graph will invert. Whatever was at the top will now be at the bottom. Whatever was at the bottom will now be at the top. The graph inverts. It reflects about the x-axis. Second part, I see there is x plus 10. So 10 is added to the function. So what happens is if I add 10, then the graph will happen quicker. It will quicker get to the result. So what happens is the graph actually shifts 10 degrees to the left because it happens 10 degrees earlier. So this graph will then also be 10 degrees to the left. So if I explain the transformation in words, so in words, the graph will be reflected about the x-axis and shifted 10 degrees to the left. I can also say the graph is inverted and shifted 10 degrees to the left. But inverted is not as clear as a reflection about the x-axis. Now we get to a very intense question, and I want you to focus for a few moments so that you can be with me on the same page. It asks here for which values of x where x is greater than 0. That's very important. So they talking about where x is greater than 0 is only those values. Now it asks us, where will the function of x multiply with the function of g be greater than 0, meaning giving me a positive result. Positive is obtained by multiplying a positive with a positive or multiplying a negative with a negative. Now I want to quickly draw something, and I want to say here this graph is positive. This graph is positive till there, 45 doesn't play with. Then this graph is negative, is positive, this one is positive, and this one is negative where this one is negative. So this result will result in a positive, and this result will result in a positive. Now I must be careful. First things first. 45, the answer there is 0. 135, oopsie. The answer there is 0. So anything multiplied by 0, the result is 0. If the result is 0, it's not greater than 0 because 0 is neutral. It's not positive, nor is it negative. It's neutral. So my answer will be as follows. From 0 degrees to 45 degrees, it includes 0. It does not include 45. Then from 90 degrees up to 180 degrees, it does not include 90 degrees because at 90 degrees there's an asymptote, and this graph does not touch that asymptote. So there won't be a result to multiply with. then up to 180 degrees, and it includes 180 degrees. I must list, however, x is not equal to 135. The very same can be said for the following. I can say that x lies between 0 and 45, it includes 0. Then from 90 to 135, but it does not include 90 and it does not include 135. Then from 135 to 180, and it includes 180 but excludes 135. I hope that was clear to you. If you missed it, maybe just rewind a little bit and go and view it again, because it's very, very tricky, and we also sometimes misinterpret the information that was asked. I just need to take you one space further here and say twice this question also came in, where they asked where is the derivative of the function of f multiplied with the function of g greater than 0. Now the first thing we need to understand is not that they want to know what is the derivative of the tan, but I need to understand the concept of a derivative. What happens when a function is increasing? What happens when a function is increasing? The derivative at a point on that curve is positive. So if the derivative is positive and the function is positive, I will get a positive result. So let's quickly analyze that one. So for those who have forgotten, anything that goes in that direction has got a positive slope. So if we take this at that point on that graph, it will be positive, and will be positive at any point as I draw tangents to that curve. Here's the other curve. If I draw tangents to this curve, everywhere it will still have a positive slope. The graph won't go in that direction. So in order to get a positive result, I will multiply for g from 0 to 45 will be positive gradient, and then from 135 to 180 degrees will also be a positive gradient. So positive times a positive will give me a positive, and a positive times a positive will give me a positive. There's no negative gradients, so there won't be a negative value for the derivative of the tan graph multiplied with the cos graph to be greater than 0. So that is the answer. It was asked twice in an exam question already. So I hope that one is very insightful for you as well. I know it was a bit of a long video. I appreciate your attention though. But just remember, when we work with derivatives of the trigonometric functions, we are actually just wanting to know what is the gradient of the tangent at a point. And that is what is important. If you can take that away from it, I know that you will have great success. We just want to know the sign of the derivative. If the function is increasing, the derivative will be positive. Okay? Keep well. All the best.